You ever had to make a choice where you weren't totally sure how it would turn out? Of course you have. We do it all the time, constantly weighing the risks and rewards in our head. But what if I told you there was a mathematical way to see into the future? Well, sort of. To predict the long term average outcome of your decisions? Well, there is. And today, we're going to learn how to use it. Okay, so picture this. You're standing at a roulette table in a casino. The wheel's spinning, the crowd's buzzing, and you've got this feeling, this gut feeling, that your lucky number is about to come up. So you decide to place a bet. But is that feeling leading you to a smart decision, or is it setting you up to lose? So that's the real question, the one we're going to crack today. You put a single dollar on that one lucky number. Now, if you did that same exact bet over and over and over again, say 1,000 times, would you end up on top? Would you break even? Or would you slowly but surely lose your money? Let's find out. Now, on the surface, this looks pretty simple. You've got two basic outcomes, right? The ball lands on your number, you win 35 bucks. Great. If it lands literally anywhere else, you lose your $1. I mean, the reward looks way bigger than the risk, doesn't it? But as you'll see, looks can be deceiving. The amazing thing is, we don't have to guess. We don't have to rely on gut feelings or lucky charms. There is a powerful mathematical tool that just cuts right through all that uncertainty and tells us exactly what to expect. And that tool, it's called expected value. It is the absolute key to solving our roulette problem and, honestly, so much more. This is the exact same concept that casinos, that insurance companies, that savvy business investors use to make huge decisions every single day. So what is it really? Think of it like this. Expected value is a prediction. It's the average result you'd get if you could repeat a situation 1,000,000 times. It's not about what's going to happen next time you spin the wheel. Nope. It's about the average over the long haul. It's basically a crystal ball for the long game. And listen, this is not just some abstract idea from a math class. It is everywhere. Insurance companies use this to figure out how much your car insurance should cost. Businesses use it to decide if a new project is worth the risk. And of course, it is the mathematical soul of every single game of chance you can possibly play. Now, I can almost hear you thinking, oh, great, here comes the complicated math. But I promise you the idea behind it is incredibly simple. We're going to walk through it step by step with a really easy example. Here it is. This is the engine that makes the whole thing run. For every possible thing that could happen, you just take the value of that outcome, what you win or what you lose, and you multiply it by the chances of it happening. Then you just add all those little pieces together. That's it. That's the whole trick. All right, let's get our hands dirty. We'll start with a question that has nothing to do with money, just to see how it works. What is the expected or average number of girls in a family that has 3 kids? Okay, first things first, we have to map out all the possibilities. From boy, boy, boy to boy, girl, all the way to girl, 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 it turns out there are 8 different combinations. This list right here is our roadmap. It's what we'll use to figure out all the probabilities. And this is where it gets really clear. We just organize everything. On the left, you see the possible outcomes. You could have 0 girls, 1 girl, 2, or 3. And on the right, we just count. For example, there are 3 different ways you could have exactly 1 girl out of 8 total possibilities. So the probability is just 3/8. And here's the final step. We just multiply each outcome by its probability and add them all up. The result? 1.5. Now, hold on. You can't have 1.5 girls, right? Of course not. And that's the absolute key to understanding this. It's not predicting one family. It's the average we'd find if we looked at thousands and thousands of 3-child families. Okay, so that was our practice run. Now let's see how this thing operates in the real world with something that affects millions of us, car insurance. Think about it. An insurance company has mountains of data just like this. They know that for a certain age group, there's, say, a 70% chance a driver will have 0 claims in a year. But they also know there's a small 1% chance that driver will have a huge $10,000 claim. So what do? They use our exact same formula. No secret sauce. They multiply each dollar amount, the outcome, by its probability. And they do this for every single possibility on their list, from 0 all the way to the max. And the result of all that? $1,100. So what does that number actually mean? It's the expected claim cost for any one person. For the company, that means they have to charge at least $1,100 just to break even before they even pay their employees or try to make a profit. Okay, you've seen the theory, you've seen it work in the real world, you're ready. It is time to go back to that casino and solve our roulette mystery once and for all. Let's just lay it all out nice and clear. An American roulette wheel has 38 slots. The winning outcome gives you a net gain of $35, and the probability of that happening is just 1 in 38. The losing outcome costs you your $1 bet, and the probability of that is 37 out of 38. And now for the moment of truth. We just plug those numbers right into our trusty formula. The value of a win times the chance of winning, plus the value of a loss times the chance of losing. Let's see what the math tells us. The expected value is -5 cents. That means for every single dollar you bet on that number, over the long, long run, you are mathematically expected to lose a nickel. That, my friends, is the house edge, built right into the math. It is not a smart bet. So, we solved the puzzle. But the real takeaway here is so much bigger than just winning or losing at a casino. Why does this actually matter to you? Because this right here, this is the real prize today. It's not just about becoming a math whiz, it's about getting a new tool for your brain. It trains your mind to stop focusing only on the big jackpot and instead to start weighing all the possible outcomes by how likely they actually are. It's a mental model for making smarter, more rational choices anytime you're facing a risk. So I'm going to leave you with this final thought. Think about the bets you make every single day. Should you buy that extended warranty on your new phone? Should you take a risk on a new career path? Invest in that stock everyone's talking about. You now have a powerful new way to think through those choices. So what daily decisions in your life could you look at with the power of expected value?